Cool, so here we have a final, quite a big improvement to the project. This here is actually a CV mixer, which will form part of the envelope circuits. I'll be using the CEM 3310 chips by Electric Druid here. They're a remake of the classic ones. Like these are actually AS 3310s. They're basically an envelope inside a chip, and you provide a voltage to each pin, and that changes your attack, decay, sustain and release time. So in order to do that, you need to make a CV mixer. So at the moment this is just one out of the 4 channels. This took a long time to get going. At first it wasn't even working at all, but after a bit of fiddling around, I've managed to work out quite a good circuit, and I had to have some help on Skype with Matt Jeffries. We were actually going through and working this out. So basically, anyway, now this pot here is well, it's taking the actually 12 volts. So if I up the knob, that just changes the bias. At the moment I currently have the CV output going into this Disting Mark IV here, so that's what you're hearing. But then anyway, this is all sent through the buffers and stuff in the TLO74, and then it's also mixed in with an LFO or CV input. So this means here I've got an LFO connected, and I can add that in as well, and this is the overall bias now. So you can see. So this will be quite handy when it's in part of an envelope, because it means I've got a CV input on the envelope, so it means I can actually modulate the attack, decay, sustain and release times. So yeah, now the next stage for this is to draw it up in dip trace, times it by 4 for the attack, decay, sustain, release, and then attach it to the envelope and see if it works. I imagine there's going to have to be a bit of fiddling around with voltages and stuff. An interesting point was here, the output of this was 0 to 12 volts, however the envelope only needs up to a maximum of 6.5, so we've just worked out that by using 2 100k resistors as a voltage divider there, by having one going to ground, it reduces the output voltage by half, so it never goes above 6. So now it's within the range we want, and perfect, ready for our envelope.